this lesson is about the properties of logs. So we have three properties of logarithms that we're going to talk about. We have the we have the product property. So if I have log base b of m times n, I can actually rewrite that as two separate log base b's of log base b of m plus log base b of n. So for the product, we turn it into addition. For quotient, for division, we're going to turn that into subtraction. So log base b of m over n becomes log base b of m minus log base b of n. And the power property says if I have an exponent, I can actually move that to the front as multiplication. So m raised to the n power is really n times log base b of m. So the first thing we're going to do is we're going to evaluate these logarithms. So we're told that log base 3 of 4 over 5, we really know we can expand that, right? Quotient is subtraction to log base b of 4 minus log base 3 of 5. And now I could take the values that we said for log base 3 of 4 and log base 3 of 5 and actually subtract them. So we have 1.262 minus 1.465. And when I subtract that, I get negative 0.203. All right, the next one, 20. To rewrite 20 as 4 and 5, that's really 4 times 5. And we just saw that multiplication becomes addition. So this is log base 3 of 4 plus log base 3 of 5. So now it's going to be 1.262 plus 1.465. And we get 2.727. For our third one, log base 3 of 25, I could rewrite that as 5 squared. And then that's really bring the power in front to log base 3 of 5. So that's 2 times 1.465, which is 2.93. So you go ahead, try these three, pause when you're ready to see the answer, hit play. All right, so for the first one, 8 divided by 5 is really 8 minus 5, so we get 0.263. For number 2, 40 is really 8 times 5, so that becomes 8 plus 5, we get 2.059. And 125 is really 5 to the third, which is 3 times log base 6 of 5, and that's 2.694. So now we're just going to focus on expanding the logarithm. So here we have the natural log of 5 over 12x. So the first thing we can do, division turns into subtraction. So natural log 5 minus natural log of 12x. So this is now multiplication, but it's all one thing. So we have natural log 5 minus, and now this multiplication turns into plus, natural log 12 plus natural log x. And I can distribute this negative to both of them. And now that's expanded. All right, this one has multiplication. So it's 4 plus, and this x has a power 3, so I can put the 3 out front, and there's my x. All right, if I wanted to do that in 2 steps, first show the multiplication turning into addition, and then worry about the exponent, I could do that, but I could also just do it all at once. So you go ahead, try the next two, pause, when you're ready to see the answer, hit play. All right, let's check our answers there. For number 4, we had 3 multiplication, so that becomes 3 as addition, and the x had a power of 2, so we moved the 2 out front. For number 5, we had some multiplication and some division, so our multiplication was plus, our division was minus, and x had a power of 5, so we brought that out front. So since I can expand a logarithm, I can also condense. So here, I know all of them are log base 10 or just log, so it's going to be log, and it's 6 times, that's a power, 3 to the fourth minus is division 3. So then I could actually do this work. I could do 3 to the fourth times 6 divided by 3, and what I actually end up with is log 162. And that's it. All right, for my second one, I have 5 to the power of 2, plus is really times x, minus is divide. So I could actually do 5 squared. So this is 25x over 4. So you go ahead, try these two, pause. When you're ready to see the answer, hit play. All right, so for number 6, we only have division, x over 9. For 7, we had 4 times 3 cubed, all divided by 12, which turns into 9. All right, so the next thing is something we've actually done, but now we're going to officially learn it, and it's called the change of base formula. If you have log base c of a, we could turn that into log base b of a over log base b of c. And normally, we can use 10 as our base and just call it log. So log base c of a is just log of a over log of c. But we could also use the natural log of a over natural log of c. So I'm going to evaluate log base 7 of 11 using common log, so that means just plain log. So that's going to be log 11 over log 7. And if I were to put that in my calculator, I get 1.232. In this one, we want to evaluate log base 2 of 19 using natural logarithms. So that's just going to be ln 19 over ln 2. And if I put that in my calculator, I get 4.248. So you go ahead, try these two, use common logs for the first one, natural logs for the second. Pause. When you're ready to see the answer, hit play. All right, so for number 8, we have log 9 over log 26. We get 0.674. For number 9, we have ln 30 over ln 12. We get 1.369. The last thing we're going to look at is some word problems. So for a sound with I in watts per square meter, the loudness L of I of the sound in decibels can be given by the formula L of I equals 10 times log I over I sub 0, where I sub 0 is the intensity of a barely audible sound. All right, that sounds like a lot. An artist in a recording studio turns up the volume of a track so that the intensity of the sound doubles. By how many decibels does the loudness increase? So if we're looking for the change in sound, we're really looking for the sound when it's double the intensity minus the sound when it was the single intensity. So that means I'm really doing 10 log 2I over I sub 0 minus 10 log I over I sub 0. And I could factor out a 10 from these. So if I factor out 10, that's log 2I over I sub 0 minus log I over I sub 0. And using some of those properties, this is really 2 times I over I sub 0, so I could turn that into plus. So log 2 plus log I over I sub 0, and I still have minus log I over I sub 0. And if you notice, these two are going to cancel, right? They're the same thing. So this turns into 10 times log 2. And this I can evaluate on the calculator, and when I do, I get about 3.01. So my answer is about 3 decibels. That's how much it increased by. So you're going to try the last problem, which is very similar to this one. We're talking about a commercial on TV being 10 times greater than the intensity of the television program. So by how many decibels does the loudness increase? Pause. When you're ready to see the answer, hit play. All right, so we're finding the change from 10i to I. So we end up with 10 log 10, which is about 10 decibels. And that is everything we're going to talk about with the properties of logs.